Hello Coven, welcome to Tech Fortified, and in this video I'm going to show you how to improve the performance of your Node.js application by 1 million times. Just imagine a situation where you have built your own Node.js application, and maybe you are aware or not aware, but um, you need to improve the performance of your Node.js application so that it can be able to process 1 million times faster. Maybe you don't know how to go about it, but in today's video, I'm going to show you how to do that exactly. So imagine a situation where you have got 1 million or 10 million or thousands of users. Now, every user, when he opens your application from the front end, is going to be making a request to your API. Now, imagine a situation where you have your database as well. So each time that a user makes a request, maybe if the request requires fetching data from database, the request has to travel down to the database to be fetched. So now, imagine every single time that the user makes a request, the request has to travel and you have about 10 million users. This will be too much for your database to handle. Maybe there are some repeated requests that needs to be cached. So how can you do to improve the performance of your own Node.js application? Well, there are some few steps that you need to follow. Maybe you could decide to, number one step is to add, first of all, add to compression module to your own server so that um, the server can be able to compress the response that's returned to the browser. From there, the browser can be able to expand it when it reaches the browser. Another great step that you need to take forward is to catch your own endpoint. So imagine a user like this website that we have over here. 10 millions of users are accessing this website at the same time. You can see that they are getting the same result whenever they visit this home page. So, but imagine if anytime they send request, this request has to travel to your server. From there your server fetches the result from the database every time. This will result in a higher number of reads from your database, of which it will not be healthy for your application. So in order to do that, you need to introduce a caching management system where you can be able to catch your own requests, some of the requests that are made to the server. And if before you could check the database to return any request, you must first of all check if there is a cache of that data, and then if there is, return it. So when you do this, follow this technique, at the end of the day, maybe the first user, the request might be slow, but subsequent users, the request will be faster because the first user makes a request to get this post, maybe up to 20 posts or 12 posts over here. You get the result from the database and then you catch it. Another user with his own device makes another request. Then you check if this data already, since it is the same request, already exists in the database, already exists in a cache management system, and then you return the cache data instead of traveling all the while to the database to fetch the request and return the response again. So you can, if you do this, you can see that your application's performance will increase by 1000 times. It will lead to a fast rendering. So like this application over here, I've already introduced the mechanism, and if for instance you decide to navigate to blog, maybe you can say at first time it takes time showing us why, to show us that it is processing. But if for instance I navigate back to home page and then I try to navigate back to the blog, you will see that you will notice that the result is much more faster as compared to the first time we visit. So if I navigate back and there is still that result in the cache, it will just fetch it and return. So what if I want to read the post? So if I want to read the post, I click on read. You can see it taking time to load the first time. If I go back to this blog again and I click on read this same post, you can see that it will render much more faster as compared to that. But you are going to be using Postman in this tutorial to test out how we can be able to see the number of seconds or milliseconds or the time taken for a request to process. So stay tuned if you want to improve the performance of your website by 1 million times. Alright, back here in our VS Code, you can see that I have two directories in my super Node.js speed. I have the client and the server. The client is basically my own react.js application. So since our focus is going to be server side, I wouldn't bother much talking about a client, because the client can be any application. It can be your Angular application, can be Vue.js, can be React, can be anything. So I'm going to be focusing on server, because this technique that you are going to use over here can as well as work with any client. So if I open my server side over here where my Node.js application is, you can see if I come down to my package.json, let's check out the packages. Well, you can see that I have different dependencies over here installed. I have the cache manager, I have the compression, I have course.env, ESS Promise, Express Helmet, and mongodb. So in this tutorial, I'm using a MongoDB. So from there, I need something to a package, a dependency to interact with MongoDB, and mongoose does exactly that. Helmet is used for setting the necessary headers when you are making a request, when you are making a inter-server communication. And Express is used to set up our Express is a framework that is used to set up our server on Node.js. ESS Promise, you install ESS Promise when your Node.js environment does not natively support ESS Promise. Yes. .env, you install it when you want to read environment variables from your .env file. So it automatically carry the environment variables that you have defined in your env file and attach it to package.json. So you install .env when you want to read environment variables. So it will carry all your environment variable that you have declared in your env file and attach it to the process and .env. We install course when you want to make inter-server communication server. Our major focus is going to be on these three. In case you are already familiar with other packages, but our major focus is going to be on cache manager, compression, and ESS promise. So these are the three packages that we'll be focusing on. So if you have not installed these packages, go ahead, open your command and navigate your project directory and install this cache manager. So it's a library. You can go ahead and check out their documentation. Also install compression and install ESS promise. We are going to be focusing on them and see how we can be able to improve the performance of our Node.js application by 1 million times. So now, if you come to our app over here, we have imported some certain dependencies. We have imported an Express, course, helmet, compression, config, Postman, MongoDB connect this. So by the way, I've set up my MongoDB connection over here. So you can see it is just a normal MongoDB. If you are familiar with the uh, creation of a REST API using MongoDB, just normal MongoDB connection that I've created and imported in my index, another app, index.js. So now, and I've created my Express code const. I've created my Express and I've used course. By the way, I'll be making, if you don't understand how to set up your course, I'll be making a video on how to set up your course in your Node.js so that you can be able to communicate with other clients or with other server-side application or client-side applications. So I've use this middleware over here. I've imported helmet and compression. I already told you that helmet is used to set up the necessary headers when you're making requests to another server or once another server is making requests to your own server. And then compression. This is one of the ways. So there are different ways by which you can be able to improve the performance of your Node.js application by 1 million times. The number one process is to use compression library. So what does compression do? Well, compression library, if you use this middleware, you install this dependency and you use it within your Node.js application, it will compress the response that is being sent out to whichever the client side or the server side that the request is coming from. For instance, someone makes a request to our own API, maybe says slash get slash answers.get slash API slash post. So when it comes to our server over here and our server happens to go to the database and fetch a post, Before it will send it to the client, if you use this middleware over here, this middleware will compress the response. So if the response is huge, maybe it is a response that will take up to 1 MB of data, it will compress it down to maybe less than 100 KB and send it to the browser. This number one technique will improve your Node.js application by up to 1 million times. So it's one of the process, one of the techniques that you need to employ whenever you're building your next Node.js application. So another step, and then over here we call our mongodb to connect, and then we imported our post route, because you can see over there at the beginning of this tutorial I showed you our application that we have created. So I created a special under the route. I created a route. I created a post route and I imported it over here, and I use it as a middleware as well. So if for instance I open this our post route, you can see within our post route that we have three routes. We have slash API slash get post slash API slash featured slash API slash post slash ID. This will get all the posts, this will get all the featured posts, and this will get a single post based on the post ID. So we'll come back to this later. So but I just want to show you the post route that I've imported in my under app index.js. So I've shown you the number one technique by which you can be able to improve the performance of your Node.js application by 1 million times, to use what compression. Compression will compress the response that is being sent out to the where the origin of the request is coming from. Be it your browser, it will send it there, and once the browser receives it, it will expand it. The next step is to use a cache manager. Now, if you're familiar with caching system, maybe you must have heard of redisdb. But sometimes when you want to integrate redisdb in your own Node.js application in order to catch data, you discover that you cannot be able to afford the cost of paying for redisdb. So, but you can be able to use what is known as in-memory store. So in-memory store, all it does is make use of your RAM. So you can be able to catch some of the frequently accessed data in your RAM, so that whenever a request comes in, it will easily get it from the cache and send it back to the user, instead of having to travel all the way down to your database. So now we are done with number one technique, is to use compression. The next step is to create a cache manager. So if within your app, all you need to do is to create a directory known as store, and inside it you will do this configuration. So this library known as cache manager has done all the heavy lifting for us, that we can be able to easily cache data. Maybe based on the request, we can easily call this, import this in cache manager, create our own store that we can be able to cache data that will be globally available. Now, what is the beauty of caching your data server side? The beauty of caching your data server side is, imagine if you have up to 1 million or 10 million users that are using your application. The first request comes in, your server processes it, and if it is something that involves database, it goes to database, fetch data, and send it back to the client. So now, within that time of sending the request back to the client, the number one client that made the request, you can choose to cache data. If you cache the data server side, and another user with another device from a different part of the world or in the same place makes request to your server with that same request URL, now your cache manager, all you have to do is intercept the request before it enters the middleware that is going to process the request, and maybe go to the database and fetch. Your cache manager or your cache interceptor will intercept the request, check if such request already exists in the cache store, and then if it exists, immediately return the data back to the another person that made the request. So now imagine if about 10 million or 1 million users are making request to the same you making the same request to your server using the same URL. Maybe all of them want to get the post at once. So you can see that this will greatly improve the performance of your application. So what does improve performance of your application? What is the effect of improved performance of your application on your users? This will help to retain your users within your application. Your users will like to use your application more because your application will be blazingly fast. So that is what you are going to do. So now, first of all, import a cache manager. If you have not installed this package, go ahead and run npm install. Another one is install an ESX promise if your Node.js environment does not support it. So once you have installed these two dependencies or two packages, now to create a cache manager, you can go ahead and check out the documentation for more ways. But this is the one that I'm using in this tutorial, one of the ways. So by the way, this cache manager support not only memory and store, but it supports redis as well. If you have redis, if you can afford to pay for redis, you can be able to change this to redis and it will detect redis extend this cache manager. So all you have to do is to call caching manager dot catching. So this catching is a function. So once you have called the catching now, you have to pass an object as options. So the number one key that you need to pass is store. You need to specify the kind of store. So your store can be none, can be memory, can be redis, can be anything. So but in this case, we want to make use of a RAM. So it should be memory. Another one is total time to live. What is the number of seconds you want your cache to live? For instance, I catch my get post. How many seconds do I want it to live in my cache memory? So by default here we specify 10, but we can be able to see how we can be able to change it based on individual route. The next one is max. The max specify the number of keys that you want to store in your cache manager. So here I specify 100. That is say the maximum number of keys that my store should store is 100. So if the number exceed 100, it will trim and remove some of the oldest cache keys. So if I have request to / get post / get users / get post by ID, all this it will be counting. Each one that it catches, it will count. So if it gets to 100, and the subsequent one comes and is 101, it will trim, remove the previous one, that is the first one. Another one is that this cache is synchronous in nature, but if you want it to act asynchronous, you need to give it a promise, provide a promise dependency. So this promise dependency now will make use of this ESX promise so that we can at the end of the day we'll be able to make use of this our store in an asynchronous way. You know that if you're using Node.js prefer functions that are asynchronous in nature, so that there will be non-blocking, they will not block the single thread. So we say this promise dot promise. So yes, this promise is a library. You can go ahead and check it out too. So and then you call module dot export is equal to store. By the way, this same technique that we have used over here, you can be able to use it in TypeScript as well. So once you have exported to your store, it is now time to make use of this store to actually be able to store data or to catch data in our store. So we have done this configuration so that our store can be globally available within our application. Anywhere we want to use this cache store, we can be able to use it. So I said come to store, create a store index.js and create this configuration. So after we have done this, the next step is to create a middleware that can be able to either set the data. We'll create a middleware and create a function, and we use that one function to be setting our data in the store, and we can use the middleware to be intercepting requests whenever a request is made to a get route. So now create another directory within your server again known as interceptors. You can call it middleware, you can call it any name of your choice, but I chose to call it interceptors because it's going to intercept our request. So inside it, you can call it index.js or you can call it cache.interceptors. So within it now, we have imported our store. We say const store is equal to require over here. So this is the store that we have required. We have required it as a global object, and we have imported it here first. Now we want to create a function that will be generic anytime that we want to set data into the cache store, we can easily call this function pass the request, pass the data, pass the total time to live, and let this function handle the setting of the cache for us. So since we want it to be asynchronous in nature, due to if you have not done this, pass this promise dependency, promise of promise, you cannot be able to use this cache in try in a sync function. So but since we have already done the configuration, we can easily create this function and use it. So now number you now create a function called store data in what in cache memory. So this function will take three parameters, which is the request. We want to get a request. We want to it to take the data. So this one is normal express request. This one is the data that we want to set in the cache, and this one over here is the total time to live. So we want it to be an optional key. So if you hover over this function, you can see that this one has a question mark to show you that it's optional. By the way, in JavaScript, this is how you provide an, a default value to a particular parameter that you want it to be optional. So with this now, we can go ahead and call this store data in cache memory with request comma data. When we want to call it without passing this TTL, which is total time to live, and it automatically pick this 60. But if you pass maybe 10 seconds over here, when we are calling the function, it will pick 10. So next thing is that in order to store data in the cache, we need to get a key where we'll be storing the data. So now to get a key, we want to make use of the request that the user is using. So if for instance a user or our client application is calling slash API slash post, we want to get this will request.url will return this. So we want to give this as a key and catch it in our cache memory store, so that any user again who makes request to this particular route or this particular endpoint, now if we will check in the store to see if this particular URL already exists in our store. If it exists, we now fetch the data, get the data from there, from the cache store, and send it back to the user. So you can see when we employ this kind of technique, the first person it will be slow because the first request is going to go to the database, fetch the result, and then we catch the result from there. Another person makes request to this same endpoint, and then we check if it exists in the cache, and then we pass it according. We fetch the data and return it to the user without going to the database, and we are going to see exactly that. So now to get our key, we say request.key. So this one just console.log the key and the total time to live so that we can be able to see. And then since our cache store is an async function, we have to await it. We say await cache store dot set. So normally if you hover over this set, you can see that set says it takes key and the value and the options that we need to pass. So now the key is our URL that the user made request, and then the data is whichever data we'll be passing over here. And then we have optional options. So but we now want to configure. Remember in our store over here we configure global total time to live, but we can be able to adjust this based on per each data that we are catching in the cache store. So that is the reason why I decided to pass it optional here, so that if you want to change the second, if you don't want your data to be cached for 10 seconds using this global time, you should make use of the time that you are going to use within a function. So total time to live, and then we say it should be whichever the value the person will provide over here. So this one just return a message to show that it's success and error is false, because if it falls within this try, if everything happens within this try and catch, well, we know that everything what our data has been cached successfully. And then in the error section or in the catch section, we now return message error occurred. So if our cache maybe there is any error over here, it will return this error for us. So we are done with this. This will be a generic function that whenever we want to catch data in our cache store, we will go ahead and call this function, pass it the required data, and it will do the needful for us. Another Another function or middleware that we'll be creating is cache interceptor. So this cache interceptor is a middleware. So by the way, if you are not familiar with middleware in Node.js, a middleware is a function that acts between the request and the response and feedback or the response time. So if I have a request, if I made a request to a particular server, by the time the request comes to the server and the server happens to process the request and send back response, my middleware can be able to act in between this request, the request time and the response time. So if maybe I want to deny the request, send it back, I can abort the mission, send it back. But if you're not familiar with that, I'm going to make a course, a video, a tutorial on middleware. So a Node.js a Node.js middleware has its own signature. So a Node.js middleware must take the request, take response, and take next as parameters. So now we now want to get the key in order to intercept when we intercept the request. So since over here in our store we are storing our data based on the request URL, we decided that okay, now this interceptor, when you are intercepting, get the request URL of where the user is making request from. And then to get the data, now we want to make this thing, we want to check our cache store to see if this particular key already exists in our cache store. If it exists, we know that the data is available. If it has not expired, we know that the data is available. So we say await cache.get. So you can see over here when we are setting, we say await cache.set. This is when we are setting the data based on the key and the time provided. So if you want to get data from our cache store, which is over here, if you check this our cache store, if you want to get data from it, you use what? The get method, and then you pass in the key. Which key are you looking for? So now this will check and return. So the data can be null or undefined. So if we now check over here, if data exists, that is say if it is neither null or undefined, then return response dot status dot data dot status code. You can decide and pass 200 over here to show that the request was successful. So you can pass 200 over here. It is up to you, and then we send back the JSON, the data, back to the user. So you can see it over here. You have checked whether the data exists based on this key, the URL that the person is making request from, and then if the data exists, we abort, we send the response back. So but else if the response, if the data does not exist, we want it to proceed to the next middleware. So when you want a middleware to pass signal to the next middleware to execute, you call this next function. And again, if it happens that an error occurred in this our try catch, again we don't want any error to stop over, any request to stop over here. We want to pass the signal to the next middleware to execute. So in this case, we are going to call this interceptor on all our get requests, so that this interceptor will always check the cache store to see if data already exists in the cache. If it exists, it will first get the data from the cache, send it back to the client, and then do not proceed to the next middleware. So in this case, if we call this cache on any get, what it will do is check if the data exists in cache store, it will return back the response back to the user, and it will not hit the next middleware of which maybe it could have made request to our database. So you can see that this will save a tons of requests that could have hit our database and maybe cause an overhead to our database to be reading or processing unnecessary request. So when the user makes request, we intercept the request, check if the data exists in the in cache store based on that request URL, and if it exists, send back the response. If the data does not exist, and then we proceed to go ahead and fetch the database. So these are all functions that we have declared. We have not yet made a use of it, but we are going to make use of it in our next. So now this we have now, as with Node.js, we have exported this in two functions. The first one is store data in cache memory, and the second function is cache interceptor. So we are now going to be making use of this store. Whenever we want to store data in cache memory, we make use of this store data in cache memory, and whenever we want to intercept a request, we call this cache interceptor. So after you have done this, the next stage now is where do we now store data in cache memory? Well, if you are familiar with the structure, I'm going to make a request on how to structure your Node.js application so that it can be easier to debug, it can be easier to read, and it will look more like a professional. So if we come under controller, if we come up under services over here, our services is the only place that we interact with our database. So under our services, you can see we have post model. This model is our database. It's where we'll be making this the one that defines our model, our database schema. So in this case, we're using a MongoDB, but it can be any database. So if we come to go to models, if we go to models, I just declare my model schema, post schema, and created my model and I've exported this. So with this mongoose, with the help of mongoose, I can be able to interact with my MongoDB over here. It can be anything. It can be MySQL, it can be Firebase, it can be PostgreSQL, it can be any database of your choice. So it doesn't matter. So in our services over here, you can see that when we want to interact with the database to fetch data, we created a function on our get post service, and then we say const post is equal to await post model, which is the model from our database dot find. So this will return all the post. So when it returns all our post, we now decide to create a return an object over here that will be returned back to our controller. We'll be opening our controller, you see it. So we say our data key should hold post status code 200 to show that it is successful, and error false message success. And then if an error occurred over here, we return data empty status code 500 error true and message error occurred. So likewise, our get featured post service is just similar to the one we have created, just that as with the node.js, this is going to take some parameters, some options like limit and skip. So we decided to find. So this is just normal a database call. It can be anyone. So when we want to get a single post, we just find post model find one based on the post ID, and you can see our data, our returning data structure is similar in all cases. So with this, it helps us to store our data in the cache much more better when we have a uniform kind of returning, a uniform format of returning our data. So you can see it over here. So at the bottom, we now exported this get post service, get single post, get featured post. So the next one, when we import this, we need to make use of it in our controller. So our controller should be the one that is interacting with our service. So controller is the one to take the request and the response and then go ahead and call our service. Remember, when you structure your application well, your service files or your services should be the one interacting with the database, and then your controller should be the one interacting with the service. So you can see we created a get post controller. We uh, first of all imported store data in cache memory, the one we created under this cache. You can see we exported it over cache memory over here. So and the next one is we imported it from there. So after we imported it, we imported get post service, get single post service, get featured post service, all from post services. And then we imported a function to check if it is an empty object. This is a function that I've created in util. This one does not matter. So get post controller now is an same function that takes a request and a response, and then it says const result is equal to await get post. So you can see when I hover over this get post, you can see the format of our data. So irrespective of whether there is an error or there is no error, we have a uniform data format that is returned. It's returning data, returning in status code, returning an error and message over here, just the way we define it in our post.service. So each function has a similar data format. So but you can have your own format that you are returning. It doesn't matter. This is the way I love structuring my own application, my own response. So now over here, we don't want to just catch the result. We only want to catch the result when there is no error. So anytime a user make request to this and we call this post as a fetch, if there is error over here, we will not catch the result. But if the error is false, you can see error is false over here, error is true over here. So we went ahead after getting the result, we now went ahead and said if not result dot is error. So this is a boolean value. If you hover over it, you will see the properties that is going to return from this object. If it is not error, then go ahead and wait, store data in cache memory. So and then our cache memory has been designed to take what? Take request and take the data. So and an optional word, total time to live. So if you want to maybe control the time to be 30 seconds in the store, we can just go ahead and say 8 or 40 over here. So and then these are 40, we go ahead and replace this our default 60 seconds that we set over here. So but if no time is provided over here, our default 60 seconds over here will take precedence over the null data or the undefined data, that will be returned. So now we specify the time. This is optional. So now we pass optional word that total time to live. So then after this, after it has catch this data, it should go ahead and return response. So you can see that when we are sending back our response over here, we send it based on what has happened. If the response is we want to send status code 500 and server side error, and if the response is successful, we want to send 200 and response. So based on the status code, we say response.status result.status code .json. Then we are sending the whole back result so that it can be sent back to the client. So likewise, this get featured post. So and in this I get featured post as well, after fetching the data using this function from our get service, we now decided to check if there is no error, and then we are wait store the data in cache memory. So if someone makes a request, maybe the request has skipped and the limit has query parameters, we now get that. We now make request based on those query parameters and get back our response from the service. After getting it, we check if the result that is returned is not having an error. If it is not having error, we go ahead and call this our store data in cache memory and pass in the request and the data and store and then return the response. Likewise, our single post will do the same thing. So all this, when you are catching your response and you want to store it in the cache, you don't catch any request other than get. Most especially if you are using you can use if you are using redis that is much more robust. You can catch your I don't think you will necessarily need to catch your post request, but that one is up to you to know what you need to do or what your application needs. So but what we are interested in this tutorial is to catch only what get request. So when we want to get a single post, after getting a post, we will check if the result is not cache. If it, then return the response. So here return the response. Our status code can be 500 or 200, so it doesn't matter. The user will get back the response appropriately. So this is where most of the logic of handling our get cache happens. So we created a generic store first. After creating it, we exported it, and then we created two functions over here. One, store data in cache memory, and we created a cache interceptor. So we have learned how to use this store data in cache memory. The next step now is to learn how to make use of this cache interceptor. Where can we intercept the request? Because we don't want the request to just go ahead and hit this our controller. before going to our services to go and hit our database. So where do we do that? Well, that is where route comes in. So under our route is where we have defined all our routes within our application. So you can see over here that we imported or require express, and then we imported all our functions from controller. And then the next step is we imported this cache interceptor. So if you don't know where to use this middleware, now you know. And then as with express, we decided to create a router, called it const route is equal to express.router. It's a function. Then we define our route. So our route will say if route.get, if a user makes request to this endpoint of /get, we now want to process the request. So now I told you that time that a middleware acts between a request time and what the response time. So for instance, now a user makes request from our application to this get post. So the request will come over here. You can see there is an interval between this our request over here and the function that is going to handle our request. In this case, is our get post controller. So you can see our get post controller. If you structure your application in this way, you can see that it is layer by layer by layer. We have defined our model as our database, where our database resides. Then we define services, where services can be able to interact with our database. And then we define controller, where a controller can be getting a response or getting a feedback or the result from services. And then we define route, where our request is going to originally come. So I told you that a middleware acts between a request and a what and a function or another middleware that is going to attend to our request. So now over here in between this request that is being made to this port over here and this, now we want to call our cache interceptor. So if you know that if by the time this request pass our cache interceptor is passed, is going to get post controller. And our get post controller now is going to call services. Services will call database. So you can see that stage by stage from one the middleware to the another. By the way, middleware execute in the order you call them. When you call this middleware over here, it will execute before passing signal to this. And the way middleware pass signal to another middleware is when you use what is known as the next function. So you can see when we created our cache interceptor, we pass the request, the response, and the next. And then we go ahead and check if the the data exists in our cache based on the key, the URL that the person made request from. And then if it exists, if it exists, we want to abort the request here, send back the response back to the user. But if it does not exist, we want to pass signal to the next middleware. So by calling this next function, and if an error occur again, we want to pass the signal to the next middleware. So over here, we intercept the request over here. So if the person made request to our route slash API slash post, then we get this key and store it. We now get this key over here. This cache interceptor will intercept the request, get this URL, and then get the for the first time it will pass because this data will not exist in our cache. So it will pass. If you make this request, it will pass this cache, this our cache interceptor. We check that there is no data and then call this next function. This next function will now pass the signal to this middleware. So this middleware will go ahead fetch the data from the database. So when it fetches the data from the database now our under our controller now, when it fetches the data from the database using a get post service, now we want to check if an error occurred. If error does not occur, we now store this data in the cache memory. So now, supposing another user again, our request, our data, our cache data based on that key has not expired, and another user make a request to this particular endpoint. So this cache over here will intercept the request over here and check if based on this particular key which we are catching our data here based on the URL, we check and see if this key exists in our cache. If it exists, get the data and then return back the response. So you can see if users continue, if you have millions of users, and the first user makes a request and then the data is fetched and then cached in our memory store, and then um, another user again makes a request to the same endpoint, you can see that this cache will intercept the request over here, get the data from our cache store, which we have defined over here, get the data and send back the response to the user. So you can see this will greatly improve our application. So the first request might take time, the subsequent request will be faster until when the cache expires. When it is expired and another user makes a request, this cache will intercept and see if the request does not exist in the cache store, it will now pass signal to the next controller. So the controller will fetch the data, and if it fetch the data and call the service to get the data, if it gets the data and there is no error again, it will store in cache memory with the time that we have defined. So you can see that this will be like a cycle. Do it, round, go. If the data has expired, do it. So if imagine you have 10 millions of users or 1 million users or thousands of users, with this technique over here, it will greatly improve the performance of your website. Your website will be pleasantly fast, so about 1 million times faster, because it is no longer hitting the database, but it is what getting the data from our cache memory and returning fast back to the user. So this is exactly under get filter too. We intercept the request. I told you all our get requests, we want them to be fast. So we intercept all our get requests. By the way, I didn't make use of put, patch or post because we don't necessarily need to catch the data under them, because like post, the data is always somehow unique to a particular user, so no need to catch. But it is the data that is going to be shared across your application. A user is making requests, another user from different part of the world is accessing your blog, accessing your website, is making requests to this post, another user too is making requests to this post, and it's the same data that is returning to them. So in such a situation, there is need to catch your own data. By the way, let me remove this from there. So now we will now export the route. So in order to make use of this route, we need to call this route in our app. So you can see the way I've structured my application. Over here under the app directory is where I've configured my app. So when I came over here, I called const post route is equal to require dot route under route, go under route and return post dot route. So since we imported it as a default, you can see, sorry, under our route, we imported it as default. So since we have imported it as default router, we can go ahead under our app. So we can go under our app and rename it to anything. It can be anything, it can be post route, it can be post router, it can be anything. So we say const post route is equal to require get post. And in order for us to use this within our application, we need to call a middleware known as use express, that is app.use. So over here down here we say app.use, but we want to for each of our requests that is coming, we want to append this after the URL, we want to append this slash API. So at the end of the day, our request will be like maybe the user is getting forward slash API slash post, because you can see over here in our app that one, as we configured it over there, when we come here we don't need to call API again. But if you don't call API over here, you can come over here and still call slash API slash get post like this API. But since for each of our route we are going to be calling slash API slash post, no need to configure it all in one place, so that all our requests we prepend this and slash API by default. So at the end of the day, our request is going to end up being like this. So and then we we call our database connection before it, and then we call our post route, and then we export our app because we want to make use of it. And now with Node.js, you know that for you to have a Node.js file to run, you can create in our server directory. If I close all this other directory, in our server directory, I still created I created index.js, which is serve as our main server. So over here, you can see that I imported .env.config. This .env is a package or dependency that enables us to read environment variables from .env. So if you have environment variable over here, we can go ahead and read it. So by the way, you can see I define my environment variables. Over here, I'm going to make a tutorial on how to structure your Node.js application in this format. With this, it makes it easier to debug, it makes it easier to add new features without breaking changes, and it makes your project much more organized. So don't mind using my database over here, because after this tutorial, I'm going to destroy this database, by the way. So now this .env package. This .env package will enable us, if you call it and call the config function, it will enable us to read environment variables. So, and in order to read my environment variable, I created a config, a directory known as config, that I decided to read all my environment variables from .env file. So you can see I've read process.env.port, I've read all my environment variables. So and then I imported a HTTP, which is a built-in module in Node.js, and then I imported this my app from this app that we configured over here. So you can see this is the app that we configured in its own separate directory over here. So the next one over here, we get the imported config from config. This is a configuration that we have done, and then we imported out of the config we have port key. We imported the port, and then we use the HTTP module to create our own server, and then passing that express server that we have imported from this particular file. So and then over here, we now want our server to listen on a particular port, because we know that as we know JS, every server must listen on a particular port. So from here, we went ahead and called our server.listen on this port. So this is the basic explanation of how you can be able to configure your Node.js application to actually catch your own request to your endpoint and then return response. So we are going to go ahead and use Postman to actually test our request and see the response time that we'll be getting in our Postman. So using a client-side software to test our application will be the same thing if we are using a browser. So by the way, a Postman simulates the way our browsers work. So it's just the same way. So we are going to and how greatly our request has improved based on the configuration that we have done in this file. So let's head over to our Postman. By the way, if you have not installed Postman, go ahead and install Postman. I'm not going to talk about Postman in this tutorial, but you can check out Postman. Postman is just a client application for making requests, for simulating our browser, making requests to our own API or server. So it works just like a browser. So you can go ahead and check out their documentation. So I'm going to go ahead and then open it. Alright, before we proceed to Postman, let's go ahead and start our server. So since I've already configured a node more, I'm going to go ahead and start my server by typing a node more. So you can see that our server is up and running and our database is connected as well. So our server is running on port 5000. It can be any port that you set up your server. So let's head over to Postman and try to make requests to those routes and see the timing, the result. Okay, now here in our Postman, you can see though for those three routes, I've created separate requests. I've created requests for getting a post, for single post, and for future post. So over here within Postman, if you click on this plus, you can be able to go ahead and add you're under collections, you can be able to create a request, or you can click on this plus to add a request. So, and if you are adding a request, you can choose if the request is it has all the HTTP method, so you don't need to worry about that. So different kinds of method you can use, but the method that we'll be using, this you use the method based on your route. The one I'll be using here is get. So, and I'm making request to localhost colon 5000 forward slash API slash post. This is the route that I'm making my request to, and the one that I've defined on my server. So I'm going to go ahead, make the request. We see the time and the response that is returned from the server. So after you have written this localhost column 5000, or specify the port forward slash API slash post, go ahead and click on this send request. So it will simulate our browser like it's making request. Well, our response is returned, and if you check your time over here, our request took about 3.35 milliseconds, and it carries the result in the store. So, and by downloading and everything, the total time went up to 3.53 seconds. So it has carried the result. So let's go ahead and make another request and see. From 3.35 seconds down to 222 milliseconds. So you can see it has greatly improved the speed and performance of our caching system, has greatly improved the speed and performance of our Node.js application. If we go ahead and make another request, you can see if let's assume different users continue making requests, you can see because that took 3.5 seconds is took 200 and something, and another 75 milliseconds is not seconds, milliseconds. The original request took 3.35 seconds, but this one is taking what, 75 milliseconds. So you can see our application will be blazingly fast. So if users continue making requests, it will be receiving different timing that is not up to the original request until the data in our cache store expires. That is when the next request will still take much time. So imagine if about millions of users are accessing the same endpoint. The first request it will catch, the subsequent request will just go to our cache store and fetch data. You can see that our application will work blazingly fast times what, 1 million times. So with this now you can have good user retention within your application. So it will continue like this until another request, until the data expires in our cache, and then the next device or the next user that will make the request, it will have to travel all the way from the database to fetch. And if we go to our CMD, you can see that I said something that if the data is returned, if we make a request and the data is returned from our cache, it should indicate that it's cache. So let's check it out. So you can see within our server here that the first request that we made, it got the post and then set the post based on, you can see the key over here, the key was slash post. So it got it and saved it in our cache. So all other subsequent requests that we're making, it was saying all this from cache, from cache, from cache. So this from cache is no longer hitting our database, but it's getting the request from our cache store and returning until again when the data got finished again, we made another request, and then this time around again it got it and saved it in our cache again, and then when we make another subsequent request comes in, it save the request, if it gets the data from the cache. So with these techniques now you can be able to improve the performance of your Node.js application. If we go to single post and we try to make request post ID, by the way this post ID that exists in my database, I just copied it and then paste. I'm making request to HTTP localhost 5000 API slash post slash this particular post ID. By the way, if you don't know how you get post ID, go to your post, the response that is returned, you can easily get one on the post ID over here and make a single post request. So let's make a request to this endpoint and see the time that it will take. Okay, when we made this request to get a single post that is returned, it took about 1562 milliseconds. So if you divide it by 1000, that is like 1.5 seconds. So now let's go ahead and make the same request again. So you can see from 1000, from 1 point something seconds to 354 milliseconds. If another request goes in, the timing will continue to decrease. You can do down to 62. If we continue making, and so long as the data exists in cache, it will continue giving us time that is less than the original request. So you can see with this application we blazingly what fast, 71 milliseconds. So you can see 90 milliseconds, 66 milliseconds. The original request took up to 1 second. So likewise, if you go to featured post has query parameters, and we are catching the URL based on this query parameter. So if our user any or our users go to application and make request to this and five localhost colon 5 times slash API slash featured slash limit is equal to 20 and skip is equal to 0, this same URL like this, it will fetch the data for a first and catch. And if another user makes request, if millions of users make request, now the cache interceptor will intercept the request, return the response, saving us database overhead. Our database could have been bombarded with requests, but with this technique of catching our data now, it will now save us what millions of requests that our database could have processed. So this will lead to a faster and highly performant application. So let's make request and see. So our first request took 985 milliseconds. Let's make another request and see. So from 85 milliseconds down to 143. So if like this one is returning from cache, so if you continue 244, you can see it got to a point. So our application will just be fast, less than the original request time until our data expires in the cache. That is when another request again we go to the database. So with this, we intercept the request. We tell the request, no, we have the data in cache. Make use of it instead of going to the database to process the request. And if we come to our own CMD over here, I decided to log the key. So you can see the key featured and limit post is equal to 20. It has cached this key for 60 seconds. And you can see that it is getting data. All our subsequent requests is sent from cache, from cache, from cache. That is getting the data from cache until this 60 seconds expires. That is when it will now go ahead. So by these 60 seconds, if you have so many requests that you want to catch within your memory, these 60 seconds may be too high. So I just say the 60 seconds catching of our request because of this tutorial, so that our data will not expire before we make another request. The time, you have to bring down the time so that the data will not be overpopulated within our memory store. So you can set the time to like 10 seconds over that, and we have created our function to be flexible enough that it can automatically do that for you. Alright, so back here in our VS Code, you can see that this stored data in memory we have created. First of all, we set the global time. They've said the total time to leave, a total time that a particular request, a particular key will leave in the cache store should be 10 seconds over here. These marks indicate the number of keys that you want to have in your store. So the number of keys, maybe if it has slide get post, slide get featured, slide like that, we want it to be maximum of 100, and this one specify the total time to live of that particular key. So each key will be cached at different intervals. So if it catch at different interval, it will take it 10 seconds to expire. But then we say we can be able to individually set total time to live per request. Then by creating this cache data in stored data in cache memory, we are able to create a function that is dynamic enough that it will take the time that you want to dynamically set, and we give it default of 60. So this 60 will override the 10 seconds that we set over here. And by passing, when you call this set, so when you call this set, if you hover over this set, you can see the set says the text parameter of key value and option. So if we expand this option, it has in TTL, total time to live. So this TTL can be a number or a function that will return a number. We intercept the request, and if the request that the user has made based on that URL, if the key exists in the store, send back the response back to the user. So, but if it does not exist, pass the signal back to the next middleware that will execute that request. So like that, in a cycle like that, it will keep on going back and forth like that. So with this technique put in place, you can be able to greatly improve the performance of your web application by 1,000,000 times, and we have demonstrated that through our Postman. So this same thing can that Postman, just imagine it's your client application, it's just the same thing. Your application will be blazingly what fast. So thank you guys for sticking around with me in this tutorial. I hope you have learned new thing. Go ahead, share this video with your friends, like and comment and turn on notification for more awesome videos like this.